Oh, so dear students and all other viewers, welcome. Uh, Today is our moment of we call that Eureka moment. Just what Archimedes had. Similarly, we will have today our Eureka moment. In what sense? In the sense that this will be your first experience of machine learning. For the first time, you will see how machines learn. At least not all the methods, one of those methods, which is the easiest to be explained, to be taught. And this method, the classification method, or what we call perceptron algorithm, we call it perceptron algorithm. Perceptron algorithm. Now, what is it? We will discuss all that. We start with a neuron. Here is a neuron. Okay. And these are its inputs. One input has weight W1 and the other input has weight W2, W2x2. Now the neuron itself, it then sums these inputs up, sums up W1x1 plus W2x2, and then if the sum of these two inputs is greater than a threshold, greater than the threshold, then it outputs 1 plus 1, provided if w1 x1 plus w2 x2 is greater than the threshold. Threshold is minus b, that is denoted by minus b. Okay, but output being 1 does not mean that value of there will be a number 1 at the output. No, output being 1 means the neuron is switched on. Similarly, we have discussed this at length already. Similarly, the output will be minus 1 if w1 x1 plus w2 x2 is less than or equal to 0. This condition, what we do, we change the form of b. We put b equal to, we have already discussed this, we put b equal to w naught and then multiply this w naught by 1. W naught is another name of b. We, instead of denoting threshold by b, we are now denoting threshold by w, and I am multiplying w by 1. That will not change it at all. And then b is equal to w naught. I will write, instead of 1, I will write x1, provided I always understand that x naught is equal to 1. So I keep it written here that x naught is equal to 1. It's unlike these x1 and x2. X1 and x2 are inputs which can change. X naught is not an input. This whole term is basically biased. But giving it this shape, you know why? You already know that. So y, w1 x1 plus w2 x2 plus, when you transpose b to this side, it becomes plus b. Plus b means you have w naught x naught. That should be w naught x naught, should be written here. W naught x naught should be greater than, now since you have transposed this to this side, you are left with 0 here. Same is the similarly we have w naught x naught plus w1 x1 plus w2 x2. Oh, sorry, I've written it here 0 already. It is minus b. It was minus b. Now w1 w2 x2 minus b is here. Now it should be less than or equal to 0. So this should be, sorry, I have not written 0 here. This should be greater than 0. Okay, with these things, now what we can do is that we have now 3 types of w's here: w naught, w1, w2. We can make a create a vector with 3 numbers. We have w naught, w1 and w2. These are 3 numbers. This is a number, this is a number, this is a number, and if I arrange them along one dimension, I call this a vector. and write it denoted by capital W. Similarly, I have three types of x's now: x0, x1, x2. So I have another vector, that is x0, x1, x2, and then this whole expression, if I multiply these two, take dot product of these two, w dot x, we show it like this, w dot x. Then I have to do one thing, I have to take transpose of this. I write wt x, wtx. Already I have taught this. Now wt means its transpose, that is w0, w1, w2 into x-axis as usual, x0, x1, x2. And when we take dot products, as you know, this dot product, the dot product that we take is simply w0 x0, w0 x0 plus w1 x1 plus w2 x2. This is the dot product. So this expression w0 x1, w1 x1, w2 x is basically this dot product, or we can also write it like this. I will use this here. So instead of this expression, I will write wtx, see, wtx is equal to this, wtx greater than 0, and here you have wtx less than or equal to 0. So I can then write this condition simply by a single this simple equation, that is y is equal to +1, that is output of the neuron is +1, that is neuron is on, if wtx is greater than 0, of -1 if wtx is less than or equal to 0. You can see it again here, wtx greater than 0 on wtx less than 0 of now going back to this, see, now suppose now what I do, I take x1 x2 plane. Here is the x1 x2 plane, x1 x2 plane, this is x1, this is x2. Both are inputs, x1 is input, x2 is input. For example, this can be height of a person, this can be weight of a person, this can be, say, cholesterol level of a person, this can be BP of a person. So both are inputs. And then now we can draw in this plane, we can draw a straight line. Say we have a straight line like this. This is our straight line. This is our straight line. This straight line divides this plane, x1 x2 plane, into two parts, this part and this part. It divides it into two parts. Okay, now for say it is okay now, but the equation of this straight line, since this is a straight line, it will have an equation. That equation must contain x1 and x2 as variables, and then this equation should be something like this. It should be, say, something like, say, 2x1 plus 3x2 is equal to, say, 12. Say 12. Okay, 2x1 plus 3x2 is equal to 12. This equation, this equation will have a graph of a straight line that lies in this plane. Can be easily checked. You can easily check it. For example, put x1, substitute x1 here, sorry, give a value to x1, you will get some value of x2. Put x1 equal to 0, so x1 is 0 here. Then this term will go, because x1 is 0. You are left with 3x2 equal to 12. 3x2 equal to 12. That gives us x2 is equal to 12 by 3. 3 4s are, 3 4s are, you know, 3 1s are, 3 4s are. So it is 3 4s are 12. Just a minute. So you have now, then so now give another value, take some other value, say 2 from this. 2 2s are 4. x1 is 2, 2 2s are 4. 4 plus 3x square, that's 4. Take that 4 to that side. You will get 3x2 is equal to 12 minus 4. 12 minus 4 is 8. So x2 is equal to 8 by 3. And when you divide 8 by 3, 8 by 3, it gives you 3 2s are 6. Then 2 6 are like something like this. So you have 0 4 and 2 2.6. 0 and 4, this is 0. And suppose this is 4 here. 4 0 4. And 2 2.6. Let this be 1 here. Let this be 2 here. 2 and 2.6. 2 and 2, this is 2.6. So I have 2 points. One is this, the other point is this. If I join them, I get a straight line. This is the straight line. This straight line corresponds to an equation. The equation is this: 2x1 plus 3x2 is equal to 12. Is equal to 12. Now, this equation divides the entire plane into two parts. One part that lies to this side will have 2x1 plus 3x2 greater than 12, and this part, this will have 2x1 plus 3x2 less than 12. Less than 12. To see that this is true, you can easily check it. For example, let's take this. We have, say, suppose we have 2x1 plus 3x2 is equal to, say, 15. Instead of 12, 15. Let's see why its graph will come. Its graph will be x1, x2. First give 0 to x1, 0. This goes 3x2 equal to 15. 3x2 is equal to 15. That gives us x2 is equal to 15 by 3. 3 5s are 5. 0 5. Now next, say you give a value of this 2 to this. 2 2s are 4. 4 goes there. That means 15 minus 4. That gives us 11. 3x2 is equal to 11. x2 is equal to 11 by 3. Now divide 11 by 3. 3 3s are 9. Then 0.0. 11 minus 9, that is 2. 3 6 are 3.6. 3.6. We can plot this graph. 0 5. 0 5. You can see this was 4. Now you have here 0 5 5. And then another point is 3.6. 3.6. This was 2 here. This is 3.6. Now this is 3.6. Where do you find this curve? On that side. You see that side. What was the graph of, what was the equation of the this straight line? 2x1. This had 2x1 plus 3x2 is equal to 15. That means the sum of these two terms were greater than 12. Similarly, you can yourself verify that straight lines on this side will have sum of these two terms less than 12. Now consider this. Consider this now. If you have this equation, suppose w1 x1 first w0 x0 plus w1 x1 is greater than minus b. Oh, sorry, I'm sorry. We have already changed that minus b into this. I'm sorry for this. So let me delete it. This is w0 x0 plus w0 x0 plus w1 x1 plus w2 x2 equal to 0. Let's take this first. Equal to 0. This will have a graph. You can draw its graph in x1 x2 plane. Remember, x0 is not a variable. It is equal to 1. You have x1 x2 plane, and we have a graph of this. Let us graph this equation. We will of course, depending upon these w1 w0 w1 w2, depending upon these, you will get a straight line. Say, suppose the straight line that represents this is this. Such a straight line. can be written in simple form as w dot x equal to 0. Why? Because this is w dot x, this much is w dot x, dot product of w and x, which can also be written as wtx equal to 0. So this is the graph of this is wtx equal to 0. Okay, right. Now what about this region and what about this region? For this region, WTX will be greater than 0. For this region, WTX will be less than 0. Okay, but we know that if WTX is greater than 0, you have here WTX is greater than, if WTX is greater than 0, output should be 1. Otherwise, output should be -1. So we can write here in this region of the plane, output will be +1, and in this region of the plane, output will be -1. This means that this line has been able to separate the data into two classes. One type of data is on this side, the other type of data is on this side. You can think as if you have obese people on this side, all these people are obese who have y equal to +1, and non-obese people on this side. Who has separated them? What is it that has separated them? It is this line. What is the equation of this line? WTX equal to 0. So if we could find this line, then we have solved, then we are able to separate the data into two classes, if we can find this line. But the question is how can we find this line? Who will finding this line? What does this, first of all, what does this mean, finding this line? It means that this line, look at this line, it is equal to 0. Now you know, dot product of two vectors, this is actually w0 x0 plus w1 x1 plus w2 x2 is equal to 0. Finding this equation means finding this straight line means finding its corresponding equation. If you know its equation, you can then graph that and draw this. But for knowing equation, you need three things. What are those? W0, W1, W2. Why not x1, x2, x3? Because you don't need x0, because x0 is equal to 1. So you already know what x0 is. It's a pure constant. Okay. You don't need x1, x2, because x1, x2 are changing. They're variable. They're not same. For example, take this point on the line. What is the value of x1 for this point? Value of x1 for this point is this. This is x1. What is the value of x2 for this point? That is this. It's x2. Now take this point. What is the value of x1 for this? Value of x1 is this. Value of x2 this. So this means that on different points on this straight line, we'll have different values of x1 and x2, but same value of these w0, w1, and w2. As you saw here. Now this equation, look at this equation. Look, is equal to 15. For example, 2 and 3 is same for every point here. What changed? We did not change these 2 and 3. We changed x1, x2. X1, x2 change, but w is same. Okay, so this means that if we could know these three numbers, then we can determine this line. Knowing these numbers means then we know this equation. After knowing this equation, we can draw a graph. So machine learning, it means knowing these numbers, knowing these weights, which weights can give us correct hyperplane. This line is called a hyperline, or it is better to remember hyperplane. We will discuss that later on. Hyperplane and hyperline. For the time being, it is simply a line, not a plane, line. Now you have so what is machine learning all about? It is about determining these true weights. Now one of these, actually only two of these are weights. The third is a bias. This is a bias. So we have two types of parameters in machine learning. Two types of parameters. One is weight parameters and the other is bias parameters. We need to know these two. If we know these two, if we are able to know these two, we then know the divider. We can then divide the data into two exact classes. Okay, the question is, how do we know these weight vectors, correct weight vectors? How do we know it? That is the last phase of this last phase of our lecture today. How do we know it? How know these? Suppose this is our plane x1, x2, and sorry, x2 here, x1, x2. This is x1, just x1. Now this is x1, x2. Okay. We have the points here. Say suppose we have one type point, one type of point. Let us denote them by dots. These are dots. One type of points. The other type of points are here, crosses. Maybe these may be obese and these may be non-obese, or something else. Anything you can think of anything, of course. Now we want a correct divider that can divide them correctly. What we do? We start with this. We take an arbitrary this weight vector. In fact, we start with no, just but before that, I'm sorry, before that you have to realize one thing, that is, wtx is equal to 0, divided the plane into two parts. In one part wtx is greater than 0, other part wtx is less than 0. Okay, these two parts have this difference. Now suppose instead of wtx, if I calculate here ywtx, this quantity ywtx, and the same quantity if I calculate here, let me see what I will get. Ywtx here. Come to this side first. This is wtx. Look, wtx greater than 0. Focus on wtx only. Ignore this y. Wtx is greater than 0. This means that wtx is positive. So this is positive. What about y? Y is in this region, y is plus 1. Y is positive. So this is positive. This is positive. When you multiply positive with positive, you get positive. This means that this will be greater than 0. Now come to this side. Come to this side. You have w into c. Y into, I have to actually take y into wtx. See, what is wtx here? Less than 0. What is that? Minus, negative. Less than 0 means negative. And what is y? Y is negative. Negative. Now negative into negative, that is positive. This means that on this side as well, this term, this quantity is greater than 0. On this side it is greater than 0. This means a correct divider, a divider which is correct, has on both sides this quantity greater than 0. Which quantity? ywtx greater than 0. This is the identity of a correct divide, this w, correct weight vector. That is how you can actually recognize the correct weight vector. On both sides of it, this will be 0. You will realize this more better. You realize it better if I show you a wrong w. Suppose this is correct w. What does that mean? This means that you will have obese on this side. These are obese. These dots are obese. On this side you will have obese, and on this side you will have these non-obese. Cross means non-obese on this side. And this line correctly puts all of the obese on one side and all of the non-obese on other side. But suppose you had a wrong w. You started with a wrong w, like this, for example. So this is the wrong, incorrect w. Incorrect w. Now the equation of I will have to draw it somewhere here separately. uh, so no, I'll have to use this. Now you have this as correct W. No, so this x1, x1, x2, x1, x2. Good. This is correct W. Let us correct W. WTX equal to 0. Correct W is this. Let me call it WC, means correct W. And this wrong W. This is wrong W. Just but before drawing that wrong W, since this is correct W, it will have these dots on this side. That means OBs on this side. This each dot means an obese person. Obese on this side, and it will have these non-obese on this side. Non-obese on this side. Okay. Now suppose I have an incorrect W, and suppose I take this as this is a wrong W, incorrect W. For this incorrect W, the equation of this line will be incorrect W x equal to 0. Just like as this was correct W x equal to 0, it is incorrect W t x equal to 0. Now look at the two sides. Look at the two sides of this line, of this incorrect line. There are some points. Say for example, take this point. What does this point represent? Obese. It represents obese because all dots are obese. This represents obese. Since it represents obese, what is the value of y for it? +1. Obese or +1, they belong to +1 category. Now what about the value of this? In this value of this is 0 for that line. What is value of this for this spot? WITX less than 0, negative, and it is positive here. WITX greater than 0, positive here. Okay. Now this is C, this is negative here. For this point, for example, for this point, WITX is less than 0, and for this point y is +1. So if you, for this point, if you multiply y with WITX, what will you get? Y is +1 because it's obese, +1. WIT is less than 0, so it is plus something, plus into minus. Plus into minus is minus, so this will be less than 0. What do you find? You find that for the incorrect line, this quantity y into w t I into x is less than 0. Being less than 0 means that it is incorrect line, because for the correct line this quantity is greater than 0 on both sides. As we calculate it here, it is greater than this, greater than 0 here, greater than 0 here. Do it and you will see, you can experience it. Now this is less than 0, so we now have this condition that we can impose upon our w. What is that condition? See, we first start with a wrong w equal to 0. W equal to 0. Let the w, this wrong w, that is incorrect w, is equal to 0, and then test this. We calculate the value of this y WIT less than into x. Into x. We calculate this. We calculate this value of this y WITX with yi greater than 0. Yi equal to 0. Naturally, if this is 0, this whole thing will be 0. So this quantity will not be greater than 0. Had it been greater than 0, then it would have been correct w, right? It will be less, it will not be greater than 0. So what will we do? We will change this weight vector, incorrect weight vector. How? We will do one thing, that is, we will add this new weight vector. All these the correct w we will denote by WC. Rest of the w's are all incorrect. They're all incorrect. So WN will be new. N means new vector. Since we have found that the weight vector we started with is incorrect, it is not giving correct values, so we do one thing, we change it. How we can change it? See, here's the method we change it, by which we may change it. Number one, w old plus we do it w old into yx. What is this? Why this w old into yx? I will tell you why. Look at these two. This is incorrect and this is correct. You see, this incorrect w and this correct w, they are not parallel. Of course they are not parallel. Suppose they become parallel. Suppose you turn this w and it is turned in such a way that it becomes parallel to this. Then this incorrect will become, at that time, incorrect will become correct. Now, how can we turn it? How can we turn this? Yes, I will tell you how can we turn it. By adding this. How do I know we can turn it? By adding this. Just look. Let us take dot product of correct vector and incorrect vector. Dot product of correct vector and incorrect vector. Let correct vector, when we take dot product of correct and incorrect, we will have to take transpose of this and this incorrect vector. Now this, let this be, let us take dot product of these two vectors after this vector has been updated, after this vector value of this has been changed. That means I will keep correct vector as such, because correct vector is constant, that doesn't change. But the incorrect vector, now we have changed it. How we change it? We add it to this incorrect vector. We added yx. That means incorrect vector plus yx. Incorrect vector. This is incorrect. Old value of incorrect vector. This old value of incorrect. This new value of incorrect vector. This too is incorrect. When you, what are you doing this thing? You are calculating dot product of this wn, this is wn, that is new incorrect vector, wn, and this wc correct vector. You are calculating their dot product. Right now the dot product will be very small because the two are not parallel. But if dot product, if they tend to become parallel, suppose this tends to become parallel, then dot product between these two will increase. Let's see whether that increase or not. This is the let me call this the new value of incorrect vector. New value of incorrect vector. Correct vector has only one value. New value of old value of incorrect vector. So your new value, then old value plus yx, old value of incorrect vector. Now multiply these two, wct wio incorrect vector plus wct yx. Okay, then we have this wct wio plus, you can write this as, since y is a scalar, it has value either 1 or 0, you can take it out, you can write it here, wctx. But what is this? This is dot product. How do I know? Because it is transpose and is then multiplied with dot product between two vectors. Which two vectors? The correct vector and the incorrect vector. But old dot product, this is old because you have old here, old dot product. According to this equation, dot product between these two vectors has increased by this much, and this quantity is positive. You can see why this quantity is positive. It is y wc, but correct, into x. You know this correct w, so this quantity will have a value greater than 0. Do you remember this, or should I show you once again? Just look here. See, for this correct vector, the multiplication of these three vectors is greater than 0 on both sides. So what do you see? You see that this is positive, this quantity is positive. Adding a positive quantity to this dot product will increase this. Now when it increases, this means that dot product will increase. Increasing dot product, what does that mean? Increasing dot product means you are turning the wrong w towards the correct w, Okay, now you suppose now the new vector, new incorrect vector is wni, new incorrect vector. but it's not so much incorrect as it was before this update. Now what you do, you once again add this quantity to it yx, and then take dot product once again with this. The dot product will increase further. So you now know what you are going to do. You are increasing the dot product. That means turning the wrong vector towards the, aligning it with the correct vector. This goes on till the wrong vector becomes parallel to the correct vector. And at that stage, this product will come out to be zero even for that vector which was previously incorrect vector. Even for that, this will come out to be greater than zero. This is expressed by a flow chart like this. What we do, we start and then take the value of w. Here is w. Put w equal to 0. We give this value to w. It is we people who give this value w to it. We start with w equal to 0. This is called initialization. You initialize w to 0. W vector has all the components 0. Now do this thing. Test this condition. Testing is done in this diamond shaped this figure. Test this condition. Ask, is yw t x greater than 0? If yes, then stop. Because w is the true w, then correct w. Then if it is correct. If no, suppose it is no. Suppose no, then what should we do? If it is not greater than 0, then what should we do? We have then to do this thing. What is it? Let us see. We have to update w. Update means, what we mean by update? Update means w, in place of w we will have to write in place of this old w, we will have to write old w plus yx. Once you update this w, this wrong w, if wrong w is updated, then you again test whether it will give you this condition or not. It goes back to that. Again, it now again asks us, is this greater than 0? Now see, I am now bringing a different w to you. Please test it. If it says no, it's not the correct w, it then goes once again for update, and then it goes back after update. Again this condition is tested, then it goes back. If it does not satisfy this continues till a correct w is found. This is the machine learning. You can see yourself what we mean by machine learning. You are finding the correct weight vector. Finding the correct weight vector is machine learning. And how do we do it? You see how do we do it? You do it by using dot product. That is the moment of eureka for machine learning. How mathematics brings this about. You can see, again, you start with a wrong w, test it here, find that it does not satisfy this condition, then you update it. After updating, again test it. If you find that this condition is not satisfied, then it goes back to this. Again, it goes on till a w is reached, a w is created that satisfies this, that proves that this is correct. That w will be the correct w, and then you will stop. Yes, and then stop. That is it. I started with classification only to show you that how machines learn. What do you mean when we say machines learn? Learning means here finding the correct w, correct weight vectors. As we move now ahead, you will find that this continues with us, finding the correct weight vectors, By weight vectors, we mean two things actually: weight vectors and bias. Finding the correct weight vectors and bias. This keeps on happening till we get the correct vector. Hope that you understand it. Once again, I request you that you should not hesitate in asking me any question if you have such a question. Thank you.